Today, we're unlocking the incredible story of Chubby. It's a system that was built at Google to do one very specific job, but it ended up accidentally becoming the secret backbone for almost everything. It's a wild story about how technology sometimes has a mind of its own.
So let's start with a problem. Picture this. You have thousands, maybe tens of thousands of computers all trying to work together on one massive task. To stop them from stepping on each other's toes, they need to agree on a single leader, a boss for any given job. But, in a huge network, messages get lost, they get delayed. How do you make absolutely sure everyone agrees on who that boss is and stays agreed?
And that, right there, is called the leader election problem. It is one of the thorniest, most fundamental challenges you face when you're building systems at a massive scale. If you get this wrong, you don't just have bugs, you have total chaos.
Now, before Chubby existed, the situation inside Google was, well, messy. Different teams had their own makeshift, ad hoc solutions. And this led to all sorts of nightmares. Like two different servers, both thinking they were the master, doing the same work twice and corrupting data. For the really important stuff, if a leader machine failed, someone, a human operator, had to get paged, log in, and manually fix it. It was slow, it was risky, and it was a huge drag on reliability. So to clean up this mess and bring some order to the universe, Google's engineers built Chubby. And their core idea was just so simple and elegant. They decided to create a digital locksmith for the entire company.
Now, the most important thing to get about Chubby is what it was not. It was never designed to be the fastest thing out there. Its whole reason for existing was to be insanely reliable and always available. It was meant to be the rock-solid foundation that other, faster services could build on top of.
The easiest way to think about it is like this. Chubby provides a central place, kind of like a digital bank vault, where a server can go and ask for a key, or in tech terms, a lock. The rule is simple. Whichever server is holding that key is the master. Period. Everyone else in the entire system knows they are not the boss. It creates this crystal-clear, system-wide agreement with no room for confusion.
Okay, so how did Chubby get to be so trustworthy that critical systems like the Google file system and Bigtable literally bet their entire existence on it? Let's pop the hood and see how it works. It all starts with not having a single point of failure. A Chubby cell isn't one machine, it's usually 5 of them, all placed on different server racks so you can't lose them all at once. These 5 servers use a really robust voting algorithm called Paxos to elect a leader among themselves. Once a majority agrees, one server is crowned the master and is given a lease, which is basically a temporary license to be in charge.
Now here's the crucial part. All those thousands of other applications out there, the clients, they don't have to worry about the vote. They just ask the cell, hey, who's the master? And then all of their communication goes directly to that one single server. This creates one and only one source of truth for the entire system. All that confusion is just gone.
All right, now to really get the twist in the story, we have to talk about something called caching. The old way with systems like DNS is time-based. Your computer grabs an address and holds on to it for, say, 60 seconds. This forces you into a terrible trade-off. If you make that time short, you hammer the servers with requests. If you make it long and the server you're talking to dies, you could be trying to talk to a ghost for a long time. Chubby's caching was totally different. It was event-based. Instead of clients constantly asking, has anything changed? The Chubby master would simply tell them the moment something did. Instantly.
And that one seemingly small design decision, that event-based caching model, well, it led to something that nobody saw coming.
That's right. The tool built to be a digital locksmith to hand out keys actually became Google's internal phone book. Developers started using it not to get locks, but to find other services. Why? Because it was just so much better than DNS. You could find the address of a master server, and the very instant that master changed, Chubby would tell you. No waiting, no guessing.
And the data is just wild. I mean, look at this. It turns out that a whopping 93% of all the messages sent to a Chubby master were these tiny little keep alive pings. That's basically just clients checking in and saying, hey, I'm still here, just keeping the connection open. They weren't asking for locks. They were just listening for updates.
This constant heartbeat was the absolute secret sauce. Because every client had an open line to the master could push out updates or tell a client its cached information was no good anymore instantly. It was perfect, real-time consistency, and that is exactly why developers fell in love with it as a naming system.
And the scale this thing could handle was just mind-boggling. A single Chubby master was seen handling 90,000 clients at once. You just couldn't do that with the old way of constantly polling for updates. It was a total game changer.
So the story of Chubby isn't just about a clever piece of code. It's packed with some really profound lessons about how these huge, complex systems actually get built and used in the real world.
So here's lesson number 1, and it's really about human psychology. The creators of Chubby noticed something fascinating. If you build a service that is reliable enough, people will start to treat it as if it's completely infallible. Developers would build entire systems that would completely collapse if Chubby had even a brief outage, turning a tiny problem into a catastrophe. It's a huge warning. You have to plan for failure, even of your most reliable components.
This table just sums up the whole story perfectly. What was built to be a simple lock service became the company's main name service. What was intended for electing master servers became the go-to place to store critical configuration files. And the event system, designed to tell you about lock conflicts, became the engine for instantly discovering new services. In every case, reality was completely different from the plan.
And what's so great is that the creators were totally upfront about this. They actually wrote in their paper this amazing sentence, admitting the irony that they, the experts in distributed systems, failed to predict how their own system would be used. That kind of humility is what makes their work so powerful.
So, what are the big takeaways from all this? Well, for one, if you build something that feels familiar, like a file system, people will adopt it way faster. Also, if you focus on solving one fundamental problem, like reliability, you might just end up solving a bunch of other problems by accident. But maybe the biggest lesson is this: your users will always be your most creative and most unpredictable product managers.
Which leaves us with a really fun question to think about. Think about Twitter, right? It was designed for you to post short little updates about your lunch, and it accidentally became a global, real-time news network. What other technologies that you use every single day have found their true calling in a way their creators never, ever saw coming?